Hello everyone and welcome to this video. Today we are going to talk about a very important topic of chemistry like equation balancing, how we can balance the equations. And first, before starting example, let us discuss some rules of equation balancing. Let's take a simple example. Let's take we have water. What's the formula of water? We have H2O. Okay. In this H2O, you can see like here you have a 2 and here you have nothing. When there is nothing, it means there is 1. These two small these two small digits, sorry, what they do represent here, this 2 and this 1, they do are called subscripts. We call them subscripts. And what information these subscripts give us? The information that is given by these subscripts is that they show you the number of atoms in this particular molecule. Like this is telling you that in this water molecule, 2 atoms of hydrogen are present and 1 atom of oxygen is present. And we call them what? We call them subscripts. There's one more thing in this. Let's say we have 5H2O. We have 5H2O. Now this capital, or you can say the bigger digit which is behind the formula, this is referred as a coefficient. We call it coefficient. Okay, and what information this coefficient gives us? This coefficient gives us the number of molecules. This is called the number of molecules. So we have two things. One thing is called subscript. This shows us the number of atoms, and where you can find it, it's after the symbol in smaller. You write it very small like CO2. This 2 is the subscript here, and what here it is 1. And what is the coefficient here? Coefficient is 1. Coefficient is the bigger digit which is behind the formula. Okay, now keeping this thing in mind, let us do some revision of rules of equation balancing, and then we will solve some practical examples with hit and trial method. Okay, first rule, keep this thing in mind while balancing equations, that matter cannot be created or destroyed. Neither you can create it, neither you can destroy it. Okay, so what idea we can get from here? Whole of the concept of equation balancing lies on this, that the mass or the amount of reactant and for the product should be same. They should be equal. Okay, the number of, you can say the number of atoms or atoms should be equal. Second important point while balancing the equations is that you have to memorize, or you have to keep it in mind, that you cannot change the subscript. Subscript, ignore my spelling here. The subscript cannot be changed. Like if you have H2SO4, this 2, this 1 and this 4, they are the subscripts. You cannot change it. If you change it, eventually you change the formation of the substance. Only thing that can be changed is the coefficient. To balance the equation, we can only change the coefficients. Like we can change the number of molecules. Like we can write like 5H2O. We can write like 6H2O. Okay, but we cannot change the subscripts. And the last and the very important point is that this coefficient, it always will come in front of the molecule. You cannot put it anywhere else. Like for example, you have options like you have 5H2O. Okay, this is correct. Like this 5, it shows that there are total 10 hydrogens and there are 5 oxygens. It will be for all of them. You cannot write it like this, H250. Like you wanted to balance oxygens, so you put 5 in the middle. This is wrong. You can also not write it like this, H2O5. This is also wrong. So keeping these rules in your mind, let us start and do a question. Okay. We have an example. It says that we have C3H8 plus O2. It is giving us CO2 plus H2O, and what we have to do, we have to balance the equation. If you are starting it like it's fresh for you, you have not done many questions before, I prefer you do a rough work, a scratch work. Like you do it for your easiness. How many carbons are there on the reactant side? We have 3 carbons, so put carbon 3. How many hydrogens we have here? We have 8 hydrogens. And how many oxygens we have on the reactant side? 2 oxygens. On the product side, if you look how many carbons we have 1. How many oxygens? 2 here, 1 here. So oxygens are 3. And how many hydrogens are there? Hydrogens are 2. So if your equation is balanced, this carbon will be equal to carbon, this hydrogen will be equal to hydrogen, and this oxygen will be equal to this oxygen. If they are not equal, then the equation is not balanced. Now what we have to do? We have to do by anyhow we have to put different coefficients, and we have to try to balance it. This method is called hit and trial method. Okay, you hit and you try that the equation is balanced or not. Okay, let's try. Here we have 3 carbons, here we have 1 carbon. It's easy to make 1 3. So if you want to make it 3 1, you have to put division like the fractions, and it will make the constant more complex. So what you do, you make this 1 3. So how can you make this 1 3? By multiplying it with 3. Let's try. If we put a 3 here, so what difference it will make? It will make these carbons 3, but will also affect the oxygens, because there is oxygen here also. So what is there? 3 2s are 6, and 6 plus 1 7. So how many oxygens we will have now? We have 7 oxygens, but the carbon is balanced. If you notice one thing here, in the reactant side, this oxygen is alone. Alone means like it is not with any other atom or element. Like here the carbon is attached with hydrogen, so if you will change carbon, hydrogen will be changed also. Like here when we change carbon, oxygen is changed also. So what benefit we can get when something is alone? Like we can balance it at the end, because we can put any number here to balance it. See, now we have 8 hydrogens, and here we have 2 hydrogens. So how can I make this 8? By multiplying it with 4. When I times it by 4, hydrogens become also 8, but it will change the oxygen. So there now 3 2s are 6, 6 plus 4 is 10. Now I have 10 oxygens. Here I have 2, here I have 10. Now I will take the benefit that it's alone, so I can put a 5 here. When I put a 5 here, it becomes a 10. So this is equal to this. Hydrogens are equal, and this is also equal. So my equation is balanced now. Very important point, this what you do is basically rough work. It has no that much of importance. Like you are solving your equation here, you are doing it here, but you forgot to put these coefficients, your answer will be wrong. You have to write the equation in this way. Like you have to put the coefficients here. Okay, let's do one more example for practice. Let's have one thing I will mention here. This what is inside the bracket, it is a very important information, but it is not involved in balancing. It is just telling you that this particular compound or element is present in which form or which state of matter. Like AQ stands for aqueous. Aqueous means something that is dissolved in water. S stands for solid, and G will stand for gas, or L will stand for liquid. Okay, so it's not important in balancing. Let's start. We have Ag. How many Ags we have on the right side? We have 1. Okay, how many nitrogens we have here? We have 1. How many oxygens? Oxygens we have is 3. And how many copper? Copper we have is 1. Now let's look at the product side. Here how many Ag we have? We have here 1. How many nitrogens we have here? Nitrogens we have is 1 into 2, because it's bracket, so we have 2 nitrogens. How many oxygens we have? 3 into 2, we have 6 oxygens. And how many copper? Copper we have is 1. Again we have here the benefit that Ag is alone, copper is alone, so we can take this advantage. If we have here, see these are not same, so they are not balanced, we have to balance it. We have 1 nitrogen here, we have 2 nitrogens here, so indeed we have to times it by 2. When we times it by 2, it will change lot of things. It will change Ag also, it will change N also, it will change oxygen also. So now what happened to Ag? Ag becomes 2 here. Nitrogen also becomes 2. And what about oxygen? 2 3s are 6. So oxygens we will have here 6. Okay, so it balances for oxygen, like nitrogen is balanced also, oxygen is balanced also. But AG is disturbed. AG is here 2, AG is here is 1. So what we can do? We can put a 2 here because it's alone, so it will also become 2. When these are same, 2 equals to 2, 2 equals to 2, 6 equals to 6, 1 equals to 1, your equation is balanced. Okay. When you become like better with time, if you become better, you can do it directly also, like without taking help. You can do directly this equation. Like if you want to do directly, you don't want to do the rough work, still you can do that. Like for example, you can read the question and you can solve it. Like you say here Ag is 1, here Ag is 1. Okay, nitrogen is 1, here nitrogen is 2, so you have to put a 2 here. Now what will happen? It will disturb the Ag, nitrogens, oxygens. So 2 Ags, 2 nitrogens and 6 oxygens. Here also 6 oxygens. Yeah, here is also 6 oxygen. So it's balanced, like 6 here and 6 here. Nitrogens are already balanced. Copper is balanced, but you have to put a 2 here to balance it. The Ag. You can do directly also. Rough work is not mandatory. There is another method which is called algebraic method to balance the equations. We will discuss that method in another video. For now, take some examples and try to practice the equation balancing with the help of hit and trial method. And in another video, we will talk about another method which is called algebraic method to solve the equation balancing concept. I used to have this method as a backup method. Like you should try solving the question of equation balancing in exam with this technique, hit and trial. But if you are struck somewhere, you are not able to solve it, then you can use this method as a backup method, because as compared to this, it will take some minutes extra, and in exam the time is very important. Thank you guys, thank you so much for your time. See you later.